All right, 8th grade. We're moving on now. May 19 and 20. We're going to be focusing on this, and I'm going to repost this video for both May 19 and May 20 because it's kind of just part 1 and part 2, basically the same thing. We're going to be talking about solving the linear system using substitution or elimination. And we're going to be, it's called solving special linear systems. All right, and so we're going to talk about exactly what that means, special systems of linear equations. And it wants us to use either the substitution or the elimination. Now remember, the substitution method is when we isolate either x or y. The elimination method is when we do some adding and subtracting because we can cancel out, or elimination also includes perhaps some multiplying to make things equal so we can cancel out. So I'm looking at this one. Now nothing's isolated, so it looks like I'm going to have to eliminate. And it seems to me that what I want to do, at least for me looking at this, is I want to take 2x and I want to multiply everything by 3. Because then that will give me 6x here. So this second equation, 6x plus 7y equals 10, is going to stay the same. And then I'm going to take this equation and I'm going to multiply everything by 3. 3 times this entire equation. 3 times 2x is 6x. 3 times a plus 5y is going to be a plus 15y. 3 times 14, I believe, is going to equal 42. Now to cancel out, I can see that I'm going to do 6x minus 6x. So I'm actually going to be subtracting, and that's going to cancel that out for me. So I'm going to go ahead and subtract here. 15y minus 7y, a 15y minus a positive 7y is going to give me 8y. 42 minus 10 is going to give me 32. If 8y equals 32, I'm just going to do 32 divided by 8. Once again, the number's working out very well. Y equals 4. So then I'm just going to take y, which is 4, and plug it into one of these equations. Well, I try to work with smaller numbers, so I'm going to continue to work with this first equation that we had, and I'm going to say, well, 2x plus 5 times 4, since y equals 4, equals 14. Well, then that means that 2x plus 20, because 5 times 4 is 20, equals 14. If I subtract 20 from both sides, that gives me 0. Now I've got 14 minus 20, which is going to be a negative 6. That tells me that 2x equals negative 6. And if 2x equals negative 6, x is going to equal negative 3, because negative 6 divided by 2 is negative 3. So my ordered pair, remember, it's systems of linear equations. Where does the point of intersection take place? And it's going to be x equals negative 3 and 4. All right, and so that's what's happening there. All right, you may ask yourself, well, Mr. Sack, what's so special about that? That's just what we did. That's no different. Well, you're right. And some of the problems on your paper are going to be just like this. You're going to get a solution, and it's just going to be an intersecting point. However, you're going to get some special systems of linear equations. 5x minus 5y equals negative 3. Y equals x plus 0.6. Well, here y is already isolated and tells us that y equals x plus 0.6. So I'm just going to plug in x plus 0.6 for this y here. All right, so I'm going to end up with 5x minus 5, and since it's 5 times y, y equals x plus 0.6, x plus 0.6, and it tells me that that equals negative 3. All right, so let's see what happens here. All right, So I'm going to figure this out here. All of a sudden I get 5x minus 5 times x, which is going to be minus 5x. Okay, well, that's interesting. And then 5 times negative 5 times 0.6. If I plug that into my calculator, it's going to tell me that it equals negative 3.0. So it's going to be, that's going to be negative 5 times 0.6 is going to be equal to negative 3. And that whole thing equals negative 3. Well, 5x minus 5x is nothing. Okay, so that whole thing can just be canceled out. And that leaves me with negative 3 equals negative 3. That should look familiar, 8th grade. That should tell you that these two lines are the same exact line. There's nothing different about them. They have infinite solutions. That should sound familiar. Infinite solutions when we get negative 3 equals negative 3, or we get the same thing on both sides of the equal sign. All right, so we're going to look at one more example.